Hi guys, Buildzoid here, and today we're going to be taking a look at sort of my initial discoveries when it comes to trying to overclock the 5700X3D. Um, so the setup that I'm on here is a Gigabyte B550 Vision D-P, which is a motherboard that was generously donated by a viewer like several years ago. And then the memory kits, the memory sticks that I'm using over here are some Viper, like Patriot Viper Steel DDR4 4400 CL19 single rank Samsung 8 gigabit B-Die memory sticks. The XMP is not enabled, of course, because 4400 does not work. Well, I mean, on this board it does work, but you wouldn't want to use it anyway. Like, from a performance perspective, it's not ideal, and when you're pushing the BCLK this much, that would actually be very unproductive. So the memory is currently at just like 3400 to 14, and this is, like, you might be like, that's not a very high memory speed, and yeah, that's one of the side effects of this whole BCLK overclocking thing, is that things get janky. Very, very janky. So anyway, and you might be wondering, why am I using a B550 motherboard? Well, that's very simple. X570 motherboards do not support BCLK overclocking in my experience. You raise the BCLK on an X570 motherboard by more than like a megahertz, and the chipset just checks out and the motherboard refuses to post. So if you're going to mess around with BCLK overclocking, you want a B550 motherboard or an A520 motherboard. I'm serious about that. A520 motherboards generally have better BCLK overclocking support than X570 boards, though those have issues in other ways. Um, actually, sort of what I'm most interested in trying with this CPU is an X470 or an X370 motherboard, because on those boards you can actually get an external clock gen, and the built-in clock gen of Ryzen CPUs only goes to like 119 megahertz. So we're kind of limited on frequency in terms of that. Though, funnily enough, the CPU already seems to be running into a core voltage limitation. Even though the default voltage on this CPU is like sky high, like 5700X3Ds run at like 1.2 to 1.25 volts, which is like, especially, well, at 4.2 gigahertz, that's actually not that insane, but at the stock 4-ish gigahertz that these CPUs run at, that is actually just an insane amount of voltage. But anyway, let's quickly run some Cinebench just to sort of show that, this kind of works. Well, I said quickly, but this is just an 8-core CPU, so this is going to take a bit. Though I guess we could take a look at the CPU specs. So 5700X3D up to 4.1 gigahertz. In my experience, it tends to run at like 4.05 for single-threaded workloads. And for multi-threaded, like even Cinebench runs at like 3.95. So this is basically a 4 gigahertz CPU. It's really kind of wacky in that sense. Now, admittedly, there are workloads that'll bring it down into like the 3.8 gigahertz range, but very small frequency range on this chip, like very, very small. Like, there's other Ryzen CPUs that, like all core boost, like all core, like depending on the workload, your all core clocks will be somewhere between like 4 and 4.4, and then your single core will be up to like 4.75. And this thing basically has like a 200 megahertz. It's not even really 200 megahertz. It's like 100 megahertz of like frequency range between like Cinebench and single-threaded workloads. And then there's like Linpack and Y-Cruncher, which will drop down into like that 3.8 range. So yeah, very, very small like frequency range on this. And also what's crazy to me about this CPU is the stock vid is really high. It runs at like 1.25 volts basically all of the time, which is insane for a 5000 series Ryzen. So yeah, and the thing is that thanks to that insanely high stock vid, these CPUs, like, you actually have like you don't have to raise the core voltage, and you can run like 4.2 gigahertz all core. Admittedly, just for Cinebench. I imagine if we tried to run Linpack, this is going to reset itself. Speaking of which, where is Linpack? And I think actually for Linpack, I want to have temperature readouts. Cinebench isn't too bad. The CPU actually, it really doesn't run that hot, and I might just be biased because, I've been using a lot of 7000 series, and 7000 series is basically infernal. This thing's not that difficult to cool on a 240 millimeter AIO. Now then, well, I'm gonna be really surprised if it survives even 3 loops. Honestly, I'll be surprised if it survives 1. So let's see. So obviously, initially, we're not gonna, like, first it needs to load the data into memory, and then eventually it's actually gonna start computing it. I imagine the mouse is just gonna lock up. Huh, it's running. And our core voltage is, yeah, like 1.263. This is kind of auto voltage. I did tweak the load line calibration. It's not dropping the frequency. I know the effective clocks are like lower, but yeah, that's not much of a gap. That is very surprising, but it does seem like we are riding the thermal limit. So that doesn't seem to be disabled, which is a good thing, because I would be very worried if it was disabled, right? The extra cache is somewhat fragile. CPU is pulling 134 watts. Yeah, so I am very, like, I really wish AMD... Oh, wait, no, we are actually getting some thermal throttling, so that's interesting. It's cool to see, though. Like, that's good news as far as I'm concerned. Because the thing is, if you have an unlocked Ryzen CPU and you change the core ratio, it doesn't thermal throttle until it hits like 115 degrees Celsius, at which point it turns off. So when you're manually overclocking unlocked Ryzen chips, they don't thermal throttle, they just have like a thermal limit. And this is a big improvement over stock. So stock, even with like overclocked memory, the CPU will run like 290-ish, and we're getting like 321. So that's like, it's like 10%. So not really that big a deal, which makes sense. I mean, normally this would have been running at like 3.8, 3.9, and we're running at like 4.2. So yeah, that's roughly like a 10% frequency increase, so it gives us a roughly 10% performance increase. So that makes sense. Thermals are horrible. Now, the one thing I've wanted to do is I actually really want to get past 5,600 points in Cinebench with this CPU, because that's sort of been the brick wall. Because I have had the BCLK higher than it is right now. Like right now, the BCLK, damn, no, not hardware info, that takes too long. So like the BCLK right now, I think we're at like 117. And I've had it all the way up to like 118. Except at 118, Cinebench starts to crash. So yeah, you know, that's a bit of a problem. So anyway, we're going to try set the priority to real time. And I do plan to, like, we're going to restart and raise the BCLK one more step, because previously I was doing all of the testing with auto load line calibration. I've since maxed out the LLC, so we might have a chance of it actually passing at 118. There's also a chance that the system might forget how to boot. That's the biggest problem I've run into with this BCLK overclocking thing, is sometimes you'll restart the system and it just doesn't. It just gets stuck on like memory training or something. Which yeah, not very fun, and then you have to go through like a full system reset, because yeah, it does not, like, for what like, the board just doesn't deal with that very gracefully for whatever reason, or the CPU. I don't actually know what it is locking up. It just sort of gets stuck in a loop. Actually, it looks like it's an Infinity Fabric initialization issue, or like a memory initialization issue. Oh, well, that's kind of annoying. Apparently setting priority to real time is enough to get that 5600 that I wanted. Oh. Okay, well, we'll see if we can improve on that a bit. So yeah, so normally on stock settings, the CPU spits out about 5200. And if you're not doing, well, I'll show you what the CPU setup in the BIOS is right now. But yeah, like, with how high the stock voltage on this CPU is, I think, like, it would have been really cool if these were, like, core ratio unlocked. Because AMD is shipping them with so much vCore. And what's really, really annoying is that you might think, oh, well, there's so much vCore, then there's like a ton of undervolting headroom. And, well, my experience with trying to undervolt this thing is that you try lowering the core, like because you do have negative core voltage offsets. yeah, as soon as you touch, like I tried minus 50 millivolts, um, and the CPU immediately lost a bunch of performance. So like the boost, like AM, this has been my eternal frustration with AMD's boost algorithm. It runs way too much voltage, and there's no way to tell it to just raise the clock, right? Because the curve optimizer doesn't actually really tell the CPU to run at higher frequencies. It just tells it to use less voltage, which you don't get a curve optimizer on the X3D chips. Like, oh, and I guess I should go through the BIOS and show you all the things that I had to do to make this kind of work. So first of all, like we have the CPU clock control, which is at 117. Then we have core performance boost disabled. Just all of this is disabled. Then if we go into AMD CBS and CPU common options, they're disabled again, but I'm not sure. That might be redundant. But anyway, under custom core P states, I have the P state set to 3600. And that's actually like absolutely critical for doing this. If you don't do this, the base clock of the CPU actually aligns with what's on the website. Which, funnily enough, I've never actually seen there's like no workload that you can run on the CPU that'll make it run at 3 gigahertz, which is kind of funny. But anyway, so if you don't set a custom P state, the CPU is actually just locked to like a 30x ratio once you disable core performance boost. And that basically means even with like 120 BCLK, you're getting 3.6 gigahertz at most, which is literally slower than stock. So you do need to do this if you want to sort of go anywhere. So yeah, this is like I guess the key thing to do. And you might be wondering, well, could you set it higher than 3600? I've tried that, and then it like reactivates the boost algorithm, and it gets weird again. Because my experience has been that if you just try to raise the core clock with the boost like if you raise BCLK and the boost algorithm is enabled, at a certain point, the boost algorithm like detects the BCLK overclock and just drops the core frequency. So yeah, that's why like I have core performance boost disabled, and then I have this like custom P state, and because like if you try to do this with the boost algorithm enabled, and I'm not talking about precision boost overdrive, I mean just precision boost in and of itself. That's what AMD's boost system is. It's called precision boost. Though on the 5700 X3D, it feels more like well, it's not precise because it's running so much vCore. Like seriously, it's running 1.25 volts at 3.9 gigahertz in Cinebench on auto settings, which is like, admittedly, the CPU, like, you know, based on the BCLK overclocking behavior, this is definitely not amazing silicon, but even like potato CPUs can do 4 gigahertz at like 1.1 ish. So 1.25 is insane as far as I'm concerned. But anyway, so yeah, custom core P state is like the main thing that makes this work. Otherwise, this just doesn't work. Or well, you can still raise the BCLK, as it's just you're not gonna get any improvement over stock performance. Other than that, I have the PCIe dropped all the way down to Gen 2, which is the biggest problem with doing this. Like, honestly, this is sort of the main reason you wouldn't really want to actually use this in like a day-to-day setup, because this will probably significantly nerf your GPU performance. So anyway, oh, and then for voltages, like also you'll notice like my memory settings are like weirdly slow, and the reason for that is that like I've tried like, you know, 3000, 1500, and then the memory training like doesn't get through memory training. So memory overclocking with these high BCLK overclocks gets weird, which is another reason not to do this. But hey, if you just want to, you know, see how far you can push Cinebench past what AMD ships the CPU with, this is actually totally viable for that, not anything else. And that really does make me kind of upset because the CPU has headroom, right? Like it's not a ton of headroom, but like there is room for like, because the core voltage is locked, right? So I wish AMD just unlocked the core frequency. right? Like, just gave you the ability to set the all-core frequency to like maximum 4.3 gigahertz, which probably won't work on the stock voltage, based on my testing. Though maybe, like, I don't know what the silicon quality variance on these chips is like, so I don't know, maybe there are some 5700X3Ds that would work at 4.3 gigahertz, but I don't think there's any motherboard. Well, there's definitely no B550 motherboards where you can set the BCLK high enough to do that. Speaking of that, I actually tried like 3 different boards with this CPU before I settled on using this one. So the first board I tried was the B550 Unify X from MSI. And oh no, I think the memory crashed. Yep. Well, there's your. Wait, is it? Did it? Yep, looks pretty dead. Oh, I don't think this will reset. Oh, and it's on 0D. Oh no. Please work. So yeah, this is very janky. But anyway, so I started with a B550 Unify X, and that motherboard, like, you set the BCLK above 103 and everything broke. And I couldn't figure out why. Then I tried the Gigabyte A520MH, which I got to 106, but I don't know if it had the custom P states thing. But yeah, that board, so I got to 106. That didn't actually, like, I basically didn't manage to get past the stock performance of the CPU. And it looks like we're lucky because I think it trained and it didn't clear the BIOS. Good. Okay. So we might have a second chance at getting into Windows. But you can kind of tell at this point that, yeah, this is really on the knife edge of stability. And I don't think it's the actual core clock doing it. I'm pretty sure it's like the memory controller or something being very upset about the BCLK not being 100 megahertz. Really makes me wish that, like, because on AM5, the workaround for this is that you just use ECLK. And then you don't have to deal with all of this, like, wackiness from BCLK overclocking. But AM4, actually, AM4, funnily enough, does have ECLK, but it's only supported on the 2000 series and only on like X370 and X470 motherboards. Actually, I'm not even sure that X370 motherboards support it. So, yeah. But that's also like the X470 motherboards also just have an external clock gen, which is the main reason I want to try an X470 board. But anyway, so now we're at 4.25 gigahertz. I think this is actually just going to crash because I don't think we have enough core voltage. And that's basically my point is like, I can't set, like, without physically modifying the motherboard, I can't raise the core voltage, right? And the thermal throttle, like, it still works in this like super janky overclocking setup that I've done here. Like, the thermal throttle is still active. We saw that in Linpack, right? Like, it wasn't going over 90 degrees. The core clocks were dropping. So, like, all of the safety features, as far as I can tell, are still working. I don't get why AMD can't, like, ship an X3D CPU with just the ability to force more frequency, right? Because that's like the thing is, like, the stock boost algorithm is just like it runs at 1.25 volts and it runs like 4 gigahertz. It is leaving easily 200 megahertz worth of core clock just on the table. Because the precision boost algorithm isn't really that precise. Like, that's why the voltage is so high out of the box. But so that's a 5618. Obviously, if we run that with high priority, it'll be a bit higher, assuming it doesn't manage to crash. Also, we did see some core clock drop, so I think we might be hitting a thermal limit at this point. Wait, what? Really? What's that? Okay, well, we're at real time now. So we're not going to get any, like, well, I'll know that the system crashed when, I guess, the fans, like, ramp down. Because, yeah, we're not going to get a render output while in real time. Yeah, so, like, the CPU can be overclocked. There is headroom. It's just absolutely, like, AMD's made it impossible to extract the, margin that they leave from the factory. And that's normal. Like every CPU ships with like a frequency margin because, you might put the CPU in a really terrible motherboard or a really awful cooling scenario and the CPU has to work. But yeah, like I don't get why it's like, well, you could just leave all the safety features enabled and then just let me raise the frequency. Like what could possibly go wrong? I mean, that's basically what I'm doing here, except instead of, using the core ratio like you would on a, well, the thing is, on the unlocked AMD CPUs, like changing the core ratio disables all of the safety features, but it's like I don't like that. It doesn't make sense to me that like the core ratio would be directly linked to all of the safety functionality, right? Like that doesn't make sense because I can have all of the safety functionality up and running, but with a BCLK overclock. Now, at this point, I'm relatively certain this is going to crash in Linpack. So that was a 5633. Also, I think at this point you might be wondering, like, we'll do a run with the CPU at stock settings. Like, I'm just going to clear CMOS and we're going to, oh, I should have used a memory kit where I could just enable XMP. Oh, well, Cinebench doesn't care about memory performance anyway, so that doesn't matter. And anyway, I do want to try Linpack, because I think at this point we should just see a crash. Though if we see it just like thermal throttling again, I think that would just be, well, interesting. And the sad thing is like you might be thinking like, well, okay, if you can do this with this like super janky custom P state, disable all the PCIe, disable all the boost, like pseudo, like this weird like kind of static overclock setup. What about if you leave the boost algorithm enabled and then just try raise the BCLK on top of that? Can you make like single core frequencies hit like, I don't know, 4.3, 4.4? And the answer is no, because like I mentioned earlier, if you just raise the BCLK with PBO enabled, at some point PBO, actually not PBO, but just the precision boost algorithm, so PB, yeah, it detects your BCLK overclock and it drops itself to 3 gigahertz. Which is very, very helpful. Yeah, so no, like we still have the thermal throttling going on. So I really like, see, this is the thing. Like why just not give like a frequency offset, not a peak boost override, just a hard offset, right? Like just tell the CPU to just run it like 100 megahertz higher or 200 megahertz higher. Because evidently it can do that. Um, and I think we're seeing some clock stretching at this point because we're at 1312. I mean 312 instead of like 322, which we had before. Um, but yeah, like like it just bugs me that this has to be so janky. At least on AM5, like you do have ECLK, and that's sort of like the ECLK doesn't solve the boost algorithm fighting you, unfortunately. Well, it for whatever reason, the 7800X3D has less issues with like ECLK overclocking or BCLK overclocking than the 5700X3D. Um, but instead, and the main thing the ECLK solves is that you don't have to like drop your PCIe speed and your memory doesn't get weird and all that kind of thing. Anyway, so now we're just gonna reset the. Actually, I'm not going to even fully reset the BIOS. I'm just going to like disable the BCLK overclock. So we're going to pull it up to, I think we were at like 3466-ish, something like that. 3550. And we'll just go 3553. It's a Cinebench. It doesn't actually matter, but I want the frequencies to be kind of close. We're going to just put that on auto, and I don't think I'll have to do... I'm not sure how it'll react if I don't manually set it to the correct frequency. So yeah, now we'll see how the CPU behaves on like auto settings. Actually, I'm going to set the vCore back to auto as well, just to give you a comparison point for like how the CPU behaves at stock. Oh, and we got the F9. Wait, I think it's tried skipping. Oh no. This is like the last time this board is like my favorite like one of my favorite AM4 motherboards that I own. And I don't remember it being this annoying. Then again, also it's not like it's on a like my favorite BIOS for this motherboard is F12G, which doesn't support the 5700X 3D. So I have had to like update the BIOS, and so maybe a lot of the weirdness might be a side effect of that, because I don't remember F12G being this bad. Especially when it comes to memory training. Because F9 is like a memory error, and I don't think my memory settings are that wacky, so I don't know what it's complaining about. Like, we're on single rank memory sticks. Okay, yeah, so we just ditched the memory profile. Okay, we'll just run 3200 with 1600 FCLK. That like has to work. Actually, you know what? I'll just load optimize defaults there. Not worth fighting with it. And we'll take a look at how like Cinebench behaves, and then I'll show you how like the boost algorithm just decides to turn itself off if you push the BCLK too high, which is like by far the most annoying thing that I've run into, because it basically means even like my BCLK overclocks where you aren't forced to go down to like PCIe Gen 2 and stuff. Yeah, those are still not viable because the... Why are we still getting a 93? Anyway, so now we should see the typical boost behavior. Yeah, so you can see... Yeah, so we're getting one core hitting like 4.05 every so often. It's not really not doing enough right now. And if we run Cinebench, you'll see that it runs at runs at basically 4 gigahertz. And also the voltage is sky high. It's actually even higher than when I was doing the custom P states thing. Yeah, like for the auto core voltage tuning on the the auto boost tuning on this CPU is just like this is so much voltage for 4 gigahertz. And it's just like you could easily run 4.2 if you could, just like tell the CPU to run at 4.2 instead of 4. Now, admittedly, if, the silicon lottery is a thing, so maybe some 5700 X3Ds would only hit like 4.1 on their insanely high stock voltage, but that wouldn't be like, that would still be better than like not being able to do anything. Also, this is like way higher than what I'm used to seeing from the CPU. You can see I have like a bunch of 5200s in here. But then again, well, we can just use the calculator to check if that frequency, like if that score makes sense. Because Cinebench is basically linear with core clock, which means that you can do the following. So if at 50, so at like 4.2 to 4-ish, I was getting 5633, right? That was like the highest score that I got, and that was at that 4.24-ish overclock. And then if we multiply that by our 4-ish gigahertz, okay, yeah, we should be getting about 5300. So that makes sense. So it is actually running it like as expected. So right now it is definitely running at about 4 gigahertz. I guess maybe I guess maybe when I last ran the tests, the room was like warmer or something. So the CPU boosted less. Yeah, so 5335. So, I mean, the overclock didn't make a huge difference. It's like, what, 5%, which makes sense because like 4.2 versus 4 is like 5%. But yeah. Anyway, so now we'll just like raise the BCLK without touching anything. So we'll go to like 104, which I think should be before we trigger any like major weirdness. And it would be kind of funny if 104 right now matched the like bending over backwards overclock that I did. Anyway, and at 105, we should see the score massively drop. At least that's what it did in my past testing. Like, I don't know, maybe it'll randomly decide not to do that anymore, which would be quite annoying. Also, what I find really interesting is that the like BCLK overclocking with this seems to cause the boot up time to take way longer than it normally does. Though it's better than like some of the other boards that I tried. Because some of the other boards I tried, like you started BCLK overclocking, and it wasn't like, oh, it takes forever to boot. It just didn't boot. Even at relatively low BCLK overclocks. So actually, wait. Is the GT 1030 a PCIe 3.0 or 4.0 card? No, it's 2.0 card, not 4. It's definitely not 4.0, but I can't remember if it was 3.0 or 2.0. I think it's 3.0, isn't it? Oh yeah, it's at 3.0 right now. Yeah, so with 104 BCLK, we can still run PCIe 3.0. Though I imagine this might cause some stability issues potentially. Anyway, let's run Cinebench, see what happens. Yeah, and it runs at like 4.05. This is my frustration, right? Is like if I bend over backwards, I can get the CPU to run 4.2, and you would think, right? Like previously, the CPU was running, and we'll see this from the score. So previously, CPU ran at like 4-ish gigahertz, and so you'd think, oh, if we multiply, 40, which is the core ratio, 40 times 104 BCLK, we should get 4.16 gigahertz, right? And then when you look at what we actually see in CPU-Z, it's like, nope, you get 4.05 because the core ratio has reduced itself from 40 to 39. The boost algorithm just actively works against you. Yay. This isn't new, but yeah, like, so that literally basically did nothing because the boost, like, and... well, and you might be like, what? Like, I don't know why AMD has to make like I don't get like why they don't just give you the ability to just like force the frequency 100 200 megahertz higher. Anyway, if we set 105, I fully expect the Cinebench score to drop into the like 4000s. And at this point, I'm just going to disable the PC. Actually, the motherboard should take care of it on its own. So we'll let the motherboard deal with that. this board will actually like take care of the PCIe as you raise BCLK on its own. Other boards don't. On other boards, you might have to set the PCIe speed yourself. The reason I had it set for that first setup is because of, like, the system gets weird as you keep pushing BCLK, so it was like I was trying to hunt down whatever random thing was causing the weirdness. I don't think I found it. But at least it worked long enough for the beginning of this video. Anyway, so now we're at 105. Actually, I wonder if in CPU-Z we won't just see the CPU stuck at like 3.6. Because that's basically what I think happens when you set the BCLK too high on the CPU. So oh yeah, we're stuck at 3.6. Or we're stuck on I think we're going to be stuck on the 36x multiplier. Wait. Oh. Oh. Oh, it's actually running 4.05 again. So yeah, the ratio just lowered itself more. Wait, our BCLK didn't go up. No, we're still at 104. Oops. Did I not set it to 105? Also, sorry for shaking the camera. The tripod is standing on the desk, and the desk is very cheap and wobbly. I spend all my money on motherboards, memory kits, CPUs, and graphics cards, not on desks. So that's why the desk wobbles. Now, the funny thing is, I actually didn't check what happened when I last tried 105 BCLK without, like, doing anything. I just know that the score just, like, randomly fell off a cliff. So I'm thinking, like, it definitely just decided to disable the boost system. Almost. Well, actually, maybe it didn't, like, fully disable itself, but, like... Oh, no, I think we're actually stuck at base clock now. Thanks, AMD. Very cool. Oh yeah, I think we're actually just stuck at 3.2. I mean, at 30 ratio, right? Because that's the base clock. And yep, that's exactly what's going on. So yeah, you hit 105 BCLK and the boost algorithm just goes like, nope, I'm out, done, nope. You want to overclock this CPU? Well, no. So yeah, that's great. So at this point, you might be thinking like, okay, so raising the BCLK doesn't, like, if you have boost enabled and you raise the BCLK, the boost algorithm just slows down. If you raise the BCLK more, the boost algorithm literally just turns itself off. If you bend over backwards and do like a custom P state and do like everything that I had done at the start of the video, then you can technically get the CPU to run like 4.2, 4.25 almost, all core. But the whole system ends up being this weird, unstable mess where it sometimes doesn't want to reboot for reasons even I haven't figured out yet. So, like, what are your options? Actually, should we try 102? This doesn't really take that long to reboot, so let's just quickly try 102. And we will also try a negative voltage offset. That's like the last thing I want to show. Because that was the other thing that really annoyed me, was just like, okay, so you can't raise BCLK because the boost algorithm just slows down. You can't do the custom P state thing because, like, I think the PCIe or like the memory controller or like something starts to break because like booting up gets really random. Like sometimes it'll post, sometimes it doesn't. And the memory overclocking with like a hefty BCLK overclock gets very wacky. And then it's like, okay, and there's no curve optimizer settings. You do have PBO, but there's not really like, yeah, you can raise the power limit, but the CPU isn't power limited. So, that's like, that's not going to do anything. Um, and there's like, you do have the scaler, but the scaler doesn't really do anything. Not for performance. It like changes the voltage behavior a bit. Um, so yeah, like this thing is like really locked down. Um, and I think really the only way to get like substantial frequency over, like substantial overclocks on one of these would be like an X470 motherboard with an external clock gen, and then also a volt mod so that you can bypass the core voltage restrictions that are enforced in the BIOS. And that's the thing that just like really, it's like there's a core voltage limit. The thermal limit exists. Like the CPU is packed with safety features. Just make a frequency offset function. Oh, finally a 5392. So yeah, very mild BCLK overclocks actually don't don't upset the boost algorithm very much. So, you can get like 4.1 gigahertz all core, I think, ish, something like that. Yeah, you can get like 4.1 probably. Okay, so 4.07. 4.1 sometimes. So yeah, like, but the thing is like if you could run a more substantial BCLK overclock, you'd be like, well, you're single threaded, you could maybe get like higher single threaded clocks, and then the all core clocks being lower wouldn't be too much of a problem. But of course, yeah, the CPU gets very upset when you raise the BCLK too much. So, or more like the boost algorithm gets very upset and turns itself off if you raise the BCLK too much. So, that's not helpful. And then there's, of course, let's just run like less voltage. So let's try running less voltage. But the thing is, like, the CPU is basically on the highest ratio already. So it's not like there's anywhere to go from here. So we're gonna start with a nice mild minus 24 millivolts. And I'm just gonna check the LLC. We're on auto LLC. If this ends up being slower, I'm gonna be so disappointed. I expect it to not do anything just yet, but that's mostly a guess on my part. Now, especially with undervolting on Ryzen CPUs, I recommend that you don't like monitor the clocks and you just look at performance and benchmarks because in my experience with Ryzen CPUs, undervolting will very often cause clock stretching. And a lot of frequency, like a lot of the time, that isn't particularly visible in the frequency readouts because the boost algorithm runs on like a 1 kilohertz refresh rate, which basically means it can change the core clock 1,000 times per second, which you're not necessarily going to see what is going on in monitoring software very closely. And actually, the clock stretching happens at an even like finer uh, time scale than the main sort of dynamic frequency behavior. Um, so yeah, if you're messing with undervolting on any Ryzen CPU, in my opinion, the only thing you should do is look at the performance. And as you can see, the performance has gone down because AMD does not like it when you overclock the CPU. Like the funny thing is like we're lowering the voltage and it's slowing down. Yeah, it is. It is actually like, so the core voltage is lower. We still have that 102 BCLK, and now the CPU runs at 3.9 gigahertz. We lowered the core voltage by 24 millivolts. At the start of this video, I showed you this CPU running 4.2 gigahertz at 1.2 like 5-ish volts, right? Like the core voltage was basically the same as it is right now, and we were at 4.2 gigahertz, and it was happily running Cinebench. Like that's how we got that like 5600 points over here. And then when you're on the stock boost algorithm, you so much as dare look at the core voltage the wrong way, and it immediately drops the core ratio. Like, do not. So yeah, I gotta say I'm very, yeah, it's just slower, and I imagine if we keep lowering the core voltage, it's just gonna keep getting slower, isn't it? Um, so that's 25. That's a 25 millivolt undervolt, and we just lost like 100 points in Cinebench. Um, and the CPU run, like the stock voltage is high enough to run at 4.2 gigahertz for specifically for Cinebench. Though funnily enough, it's not like it crashed in Linpack. It was just thermal throttling. So who like honest like okay, well, let's try minus 54. It can't possibly get any worse, can it? I mean, we could also maybe just try drop the BCLK back down to a... no, we'll keep the BCLK and we'll just drop down to minus 54 millivolts. Um, I'm actually not sure what this is going to do. I don't... we might end up at less than 5,000 points at this point. I'm not sure. Um, But yeah, so if you're basically if you're buying a 5700 X3D, you can raise the BCLK by like a 2 megahertz, maybe 3 megahertz, and that's it. It's like you do anything more than that, and the CPU is just gonna no, you know. Um, and it is like honestly, I'm quite disappointed by that, especially because the stock core voltage is so damn high. Like it's one point like it runs at like 4 gigahertz, and it uses the kind of voltage that, admittedly, on like non-X3D CPUs, you would expect like 4.5 or something. Um, oh wait, I opened up hardware info. That's no. The thing is, hardware info's monitoring like eats up like hurts the Cinebench score more than CPU Z. So anyway, okay, well now we're idle, so the core voltage reading is going to be lower. But okay, so we're and the core voltage is still the same, and the frequency is actually still the same. Wait, no. So now the core voltage is a bit lower, and the frequency is it's about the same. So, yep, that's maybe a smidge higher. Um, so perhaps if we go all the way down to minus like 100, it'll be faster. Though let's not get too excited. Who knows? Maybe it's clock stretching, and the performance will be the same as it was before. Um, But honestly, like the CPU actually just runs at higher frequencies if I didn't touch anything in the BIOS. Okay, yeah, so the performance basically did not change from the previous run, and, well, I guess let's try minus 100. Um, like, obviously, there's minus 75, but I'd like to, my approach to a lot of overclocking is to, like, find the limits quickly. Like, where does, because, like, testing things that work doesn't give you useful information. Testing things, like when you get to something that doesn't work, you could note that down as like, okay, that's too much. Whereas things that work is just like, well, it, there's headroom, right? It's not like you still have more stuff to test after testing something that works. Um, So who knows? Maybe at minus 100 things might pick up, though. I also wouldn't be surprised if it just kind of spat out the same score again. And this time I won't open CPU-Z. At least not for the first run. We might run it twice depending on what kind of score it spits out. If it spits out the same score, then it's running at 3.9 gigahertz again. That's the nice thing about Cinebench is you can literally use that score as basically a frequency indicator. Because it really doesn't care about anything other than core clock, especially on Ryzen CPUs. Like some earlier, like some like DDR3 era CPUs, Cinebench would potentially actually be somewhat affected by memory settings. Oh, and like X299. So there are exceptions to that, but Ryzen 5000 series, like running Cinebench R20, it's a core clock test. So yeah, let's see what happens at minus 100. So on full auto, the CPU does 5339. 102 BCLK it does like 5392, right? And at 103, it might do like 5400-ish. And we're slower. We're even slower. So basically, yeah. Do not negative offset the 5700X3D. Just don't. The only thing that happens is the CPU gets progressively slower. That's it. It's like if you thought the 5700X3D was too slow, you can make it slower by lowering the core voltage. It is literally running at... Oh, that's interesting. It's reporting 3.9 gigahertz, so it's clock stretching like crazy. See, and this is the thing that like frustrates me to no end when I hear from people about how they have some massive undervolt and their frequencies are so high, and it's like and it's like, yeah, but the frequency doesn't mean anything. Like, it literally doesn't mean anything on modern CPUs, and also some on modern GPUs as well. I mean, I'm not sure about AMD GPUs, but like NVIDIA GPUs will quite happily report core clocks that are not reflected by performance whatsoever. And AMD CPUs are capable of the same thing. This is 3.9 gigahertz. This should be scoring over 5,000 points. Like, well over 5,000 points. This should be like 5,200-ish. And that first run was like 4,800. And now we have 4,855. Yeah, this is not 3.9 gigahertz. I can tell you what this frequency is. Remember, we have that calculator, and at 4.24, we were getting 5633, right? So 5633 divided by 4.24 gives us this number, and I did this backwards. I should have done 424 divided by 5633 times 4855. We are running at 3.65 gigahertz. Which, yeah, right. And also at stock settings, the CPU does like 5300-ish at like it did that like 5339 at like 4-ish gigahertz. So 4,000 divided by 5339. And then we multiply that by our garbage score that we're getting at minus 100. Yeah, it's running at like 3.65 gigahertz. Like it's running at like, yeah. And that's why we don't look at frequency readouts. Because they're made of lies. I wonder if the effective clocks reflect this behavior. Because sometimes they do, sometimes they don't. Okay, in this case, hardware info is spot on. Yep, that lines up with the performance that we're getting. So yeah, it just clock stretches harder and harder. The more you undervolt it. So yeah, 5700X3D is like it is locked down. Or well, it's not so locked down that if you want to run some like purely academic experiments like, hey, can a 5700X3D run Cinebench at 4.2 gigahertz? Yes, it can, but the rest of the system becomes completely unusable at that point because of the massive BCLK overclock. So it's not as locked down as like non-K Intel CPUs, because non-K Intel CPUs you set the BCLK above like 103 and the CPU literally refuses to boot up. Um, but yeah, like as far as like overclocking for your daily setup, you can raise the BCLK like depending on what motherboard you have. You can try raising the BCLK to like 102, maybe 103, and that's it. You should not do anything more than that because it just the CPU just like doesn't like at 105 BCLK, the boost algorithm turns itself off. At 104, the boost algorithm is really fighting you to make sure that it's not, boosting too hard. Um, and then if you start if you start negative voltage offsets, well, the CPU just just underclocks, like clock stretches itself, into running at like 3.6 gigahertz while reporting 3.9. Um, so yeah, the CPU is like, if you're building a system around it, basically you can mess around with overclocking your memory. You can, do that 2% overclock with the BCLK. I guess the nice thing about a 2% BCLK overclock is that it's relatively unlikely that it's going to cause any major issues. At the same time, it's not like it's impossible. I don't like. There might be like M.2 SSDs or something that are like super sensitive to variation in PCIe clock, and if you raise it by 2 megahertz, that they might stop being detected or something. Um, though I don't use enough M.2 SSDs to know how common of an issue that is. Um, SATA drives don't have problems with that like at all, basically. Well, okay, that's not true. There, you can actually like, though I'm not sure if that's an issue with AM4, but there are definitely like that is a potential issue. But that usually happens at like insane BCLKs. But anyway, yeah. So that's kind of it for my sort of exploration of overclocking a 5700X3D. Is like, can it be done? Yes. Should it be done? No. Is it is it janky? Hell, extremely. Um, and if you're thinking about just dailying the CPU, you're best off just kind of not touching anything but the memory, I think. Um, yeah, because honestly, with the thing is like 2% BCLK, it's like, yeah, it's not like, there's like well, if you stack that on top of your memory overclock, and then it's like, yeah, but also it's 2%. Like, it's not nothing, but it's basically nothing. So, I don't know how much for a daily system, how much I would be willing to like run the risk of it causing some major stability problems. Um, so, though I guess you could like, if your system isn't like too important to you, and like if you're just doing a gaming build and you don't necessarily mind if you like crash out of a game once, you could just set the BCLK overclock and then just roll with it. And if any issues show up, you can just turn the BCLK overclock off, right? Like that is an option. Um, because the main issue with the BCLK overclock is like, it's not really a question of like stress testing the CPU. It's like, well, how's your GPU going to react to it? How are your storage devices going to react to it? Or like USB port, maybe some USB ports might get weird with it. I really don't think at 102 BCLK that's a massive concern, but it's not impossible. Because yeah, on AM4 the BCLK does actually affect everything. Um, so Yeah, whereas on certain other platforms, BCLK overclocking like doesn't really cause those kinds of issues. Well, anyway, that's it for the video. So hopefully you found this somewhat interesting, if not particularly useful. And big thank you to the channel supporters for, funding the purchase of the 5700X3D. And with that out of the way, thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And that's it for the video, so thank you for watching, and goodbye.